Hello everyone, in today's tutorial, we will learn the design and assembly of bevel gear in SOLIDWORKS with the help of toolbox, and we will cover the material selection for bevel gear. Along with that, we will see how to make this motion study animation. So let's get started. When we open SOLIDWORKS, select New, select Assembly, click OK. This window will automatically pop up to select our old files to assemble. For now we will cancel it because we can make gears by using toolbox and assemble it directly. So first we will change this IPS to millimeter gram second. Now go to design library, select toolbox. If you don't have toolbox option here, select the small arrow besides of option, select add-ins. Here SOLIDWORKS toolbox library, select these two box, click OK. Again go to design library, select toolbox. Here we have so many options. If your values are in inches, then select ANSI inch. ANSI is American National Standards Institute, so you can select that. Our values are in millimeter, so we'll select ISO. Select power transmission, select gears, and drag and drop the bevel gear. Remember one thing, if you have selected assembly option, then only this menu of configure component will open. If you have selected part, then this menu will not open directly. So we have to change these values. We will select module 14. Number of teeth, we will select 34. Pinion number of teeth, we will select 17. Pressure angle, we keep it 20. Face width, we will change it to 80. This is face width. Hub diameter, this small is hub. Hub diameter, we will select 200. Mounting distance, we will select 300. Nominal shaft diameter, we will select 80. This is the nominal shaft. Keyway, we will select rectangular 1 because we need only one slot for key. This is the slot for key, and select OK. Now system will automatically copy this gear. We don't want it, so select cancel. So this is our main gear. Now again go to design library, and this time we will select pinion bevel. So drag and drop this pinion bevel. Again we will change these values for pinion. So we will keep module 14. Number of teeth, we will select 17. Gears number of teeth, we have already selected 34. Pressure angle, we keep it 20. Face width, we select same as main gear. Hub diameter, we'll keep it 75. Mounting distance, we'll make it 300. And this small is the nominal shaft, so we'll change it. We'll select 40. Keyway, again we select rectangular 1. But remember one thing, these are the random values. You can change it as per your calculations and requirement, and click OK. Then it will copy it. We don't want, so cancel it. Now right click on main gear and select float. Now we have to give relations to them. For that, select mate. One of these two gears should be fixed or unmoving, so that we will fix this main gear. For that, we will select origin and select this shaft hole and select concentric and click OK. But you can see this gear is still moving and we don't want it. So we will restrict this movement by giving some other relations. So click on this small arrow, select top plane and select this surface of main gear and select relation coincident and select OK. Now see, this gear is rotating properly and stable at one place. Now we have to give some relations to pinion as well. So click on the small arrow front of base revolve and right click on sketch and select show. Do this same for the pinion as well. Click on the small arrow and right click on the sketch and select show. Now select these both center point and give relation coincident. Select OK. Now we will give perpendicular relation to this both gears. Select this center line and select center line of main gear and give relation perpendicular and select OK. Now you can see gear is moving perpendicularly. Now we will stable this pinion at one plane. For that, select the center line of the pinion gear and here select front plane and select relation coincident and click OK. Select OK. Now you can see these both gears are rotating properly and stable at one place. Now hide this sketch. Right click on the sketch and select hide. Again, right click on the sketch, select hide. If you want to see your gears collide or not, select move component. Select standard drag first and try to move it slightly. Okay. Select physical dynamics and then try to move your gears. If your gears are not meshing properly, then system will detect collision. These gears are looks perfect, so we'll click OK. Let's look at the important aspect of material selection. The materials used to manufacture bevel gears are cast steel, plain carbon steel, alloy steel. Depends on the requirement of high strength and high toughness. The material selected based on the strength calculation, available space and cost of material. So you can select your material based on your calculations and requirement. So we will select steel. Go to the appearance. Select metals. Select steel. Drag and drop the polished steel and select body. right click on it and you can copy this appearance and right click on pinion gear and you can select here paste appearance and select body. Now we'll see how to make this motion study animation. Go to the motion study. If you don't have this option here, right click here, select toolbars, select this motion manager. Here, select motion analysis. If you don't have this option here, go to SOLIDWORKS add-ins and select SOLIDWORKS motion. You can select basic motion as well, but motion analysis is quite efficient. So we'll select motion analysis. Drag this point up to 20 seconds. Select motion study properties. Frames per second, we'll put 30 frames per second. Click OK. Now select contact. Select this both gear for contact and click OK. Now we'll select motor. You can select any of this shaft for motor. For now, we'll select main gear shaft as motor. And if you want to change the direction of motor, click on this box of reverse direction. Speed, we'll keep 3 revolutions per minute. And rotary motor, click OK. Now select on calculate. It will take couple of seconds to calculate. So this is our bevel gear motion animation. If you want to save this, click on save animation. Select the file where you want to save your animation. Here file name, file type. I always prefer MP4 file type. Aspect ratio 16:9. Frames per second, we will select 30 frames and select save. It will take couple of seconds to save. If you have any query, ask in the comment section. If you find this video informative, like this video and subscribe to the channel for upcoming educational videos. So this is our final animation and thanks for watching the video.